Students, let us check the first topic in Unit 2, Understanding Economic Growth. To introduce the topic, let us understand growth for a nation is measured as a growth of GDP or per capita GDP. The percentage change in a country's output or income from time period T to time period T plus 1 is the growth rate of the country's economy. If GDP is an indicator of economic growth, then are the countries with high growth rate of GDP richer or more developed? And are countries with lower growth rate of GDP poorer or less developed? The answer is not easy. GDP growth rate increases as a possibility of economic development and welfare. But countries with high growth rate of GDP are not always developed, and those with low growth rate are not always less developed. Hence, sometimes such figures appear misleading to laypersons, and hence it becomes important to evaluate the growth process of economies. The objectives of this lecture are: first, to get an idea regarding measurement of growth; second, to understand the parameters which cause GDP to rise; third, to understand how experts have modeled the growth process; fourth, be able to reason if a model on economic growth helps us to understand reality; and fifth, to build an initial clarity on growth models to further understand the solo model of growth. Let us have a look at the GDP growth rates of various countries. Looking at these figures, can we say that India, China, Kenya are richer and more developed than Japan, UK, USA, Sweden and Switzerland? Students, would you now immediately check the per capita growth rates of GDP for these countries? While population determines per capita growth rate, which parameters determine the growth rate of GDP? Would a high growth rate of GDP or per capita GDP imply higher development or a higher possibility of development and welfare? Students, what should we know about national income? Let us know that in the context of rise in GDP or GNP, we must understand increase in nominal incomes is valuable only if it can buy more goods. If inflation rises as much as the increase in GDP, then the increased GDP does not help to buy more goods. Hence, the real GDP must rise over years. Real GDP is the income adjusted for inflation. If population growth rate is very high, then per capita GDP growth rate will be lower and personal welfare increases when there is a rise in per capita income growth rate. It is also important to note that per capita incomes are only mathematical averages. The real distribution of incomes may be highly inequitable and a significant proportion of the population may be earning much lower than the average per capita income, while a few people may be earning much higher than the average per capita income. For welfare of societies, growth must occur continuously for a long period of time. The sources of income, that is, the types of activities from which incomes are earned, determines the growth of employment over a long period of time, and employment over a long period of time determines savings and capital formation, and savings and capital formation determine further growth. We may thus wonder as to how we can understand economic growth. Several economists have presented models to show how certain parameters are instrumental in attaining growth. Most experts believe that savings, capital formation and population growth have a strong bearing on economic growth. However, the role of these parameters differs in each model. In order to understand the role of savings and capital formation, we must understand the Harrod-Domer model. After grasping this model, the long-term growth model presented by Solo will be easy to understand. The Harrod-Domer model. This model of growth emerged from the works of Roy Harrod in 1939 and Domer in 1946. According to this model, growth occurs when people abstain from current consumption and save. The savings result in investments in capital. With increase in stock of capital, output rises. In the circular flow model of national income, production is done by firms by employing households. In return of their work, the households earn incomes from the firms, which they spend to buy the goods produced by the firms. However, households do not spend the entire income on consumption. They may save some income which they invest. In other words, they buy capital goods. In current times, investment may be made in physical capital or in human capital. Let us explain the Harrod-Domer model with some equations. If capital Y denotes total output, capital C denotes consumption, capital S denotes total savings and T denotes time period, then YT is equal to CT plus ST. This identity implies that at any given time period, output produced is equal to consumption goods plus investment goods, or income earned is spent on consumption and savings are then used for investment. Now, we can also write YT is equal to CT plus IT, where IT is the investment in time period T. We must note here that ST is equal to IT is a macroeconomic identity and therefore, we can use IT in place of ST. Now, investment has two effects on capital. A, it augments the stock of capital denoted by K. B, some of the new capital replaces the depreciated old capital. Let us remember now that capital assets, which in a way are factors of production, can be used in the process of production and income generation for a long period of time. But as they are used, they depreciate. In other words, their capacity to generate incomes reduces. Hence, a nation must keep on generating new capital in order to maintain and raise the GDP growth rate. If delta stands for depreciation, then K in time period T plus 1 is equal to 1 minus small delta into capital in time period T plus IT, or K in time period T plus 1 is equal to 1 minus delta KT plus ST. Let us understand this equation. The stock of capital at the beginning of time period T plus 1 is equal to the stock of depreciated capital carried forward from the previous year T plus the total of new investment made in time period T calculated at the end of that period. This investment adds to the stock of capital in the beginning of time period T plus 1. In other words, there was a stock of capital denoted by K in time period T, which depreciated at the rate of 1 minus delta and was carried forward in time period T plus 1, and a new investment IT which makes up for the new capital in period T plus 1. Consider here that period T plus 1 is the year 2017, and therefore, period T is the previous year, which is 2016. Now, the saving rate small sigma is given by ST upon YT, which means that in time period T, amount S is saved from an income or GDP of amount Y. This can be rewritten as ST is equal to sigma YT, which means the total savings ST are equal to proportion sigma of the total income YT, and the capital output ratio denoted by theta, which is equal to KT upon YT, represents the amount of capital required to produce a unit of output or GDP equal to Y. This can be rewritten as KT is equal to theta YT, which means that capital KT is equal to capital output ratio theta multiplied by the total income YT. Let us define growth rate of output, which is given as G. G is equal to Y in time period T plus 1 minus Y in time period T, the whole divided by YT, that is income in current period minus income in previous period divided by income in the current period. Thus, now equation 4, which we saw earlier, develops into theta YT plus 1 is equal to 1 minus delta into theta YT plus sigma YT. This is an important equation. This means that the growth of income at a given capital output ratio in time period T plus 1 is equal to the capital formation from income in time T discounted at the rate of depreciation plus the savings generated from income in time period T, and this translates into Y T plus 1 minus YT upon YT, which is equal to sigma upon theta minus delta. Using all these equations, we can derive that growth of national output can be increased by raising sigma, which is the savings rate, or by lowering theta, which is the capital output ratio. A higher sigma means that a nation saves more and savings translate into investments according to the macroeconomic balance given by S is equal to I. Higher investment means more capital formation, and more capital formation means greater output. A lower theta means that lesser capital is required to produce a unit of output, and so more output can be generated by the existing stock of capital. Now, equation 7 can be shown as sigma upon theta is equal to G plus delta. Dear students, we must think a little here as to how do we increase our savings. If we consume very less of what we produce in order to increase savings, what happens to the unconsumed goods which we have produced? Is there a right balance between consumption and savings? Can we recollect from the topic on national income that a country produces consumer goods as well as producers goods? Consumers goods are consumed and producers goods are used for investment. So, can we say that savings go into purchase of producers goods? What kind of investments must a country make to increase the growth rate? This model considers growth of GNP as an indicator of growth. However, GNP per capita is considered to be a better indicator of growth than gross GNP. Thus, if population is introduced in the Harrod model, we may derive equation 6 as theta into gamma t plus 1 into pt plus 1 upon pt, which is equal to 1 minus delta into theta gamma t plus sigma gamma t, where gamma is given as yt upon pt, which is nothing but the per capita income. If we divide equation 9 throughout by theta gamma t, we obtain gamma t plus 1 upon yt into p t plus 1 upon pt, which is equal to 1 minus delta into sigma upon theta. Now, gamma t plus 1 upon gamma t is equal to 1 plus g star, where g star is a rate of per capita growth and p t plus 1 upon pt is equal to 1 plus n, where n is the rate of population growth. Thus, sigma upon theta is equal to 1 plus g star into 1 plus n minus 1 minus delta. Let us evaluate the practical applicability of this model for developing countries. High marginal propensity to consume and a low marginal propensity to save. Dear friends, many developing countries have a high marginal propensity to consume and a low marginal propensity to save. That is, they can generate very small proportion of additional savings from their additional incomes. This is because they have high population growth rates, high incidence of poverty, and thus all additional incomes are used up in absorbing the increasing population or in eradication of poverty. Can this mean that rich people or rich nations always save more? There might be a possibility that the richest nations may feel that they are already on a higher level of economic well-being than most others, and hence they may be more attracted towards consuming a very high proportion of their new incomes rather than in accumulating more wealth. In this sense, even the rich nations save lesser. It might be possible that the middle class people and the middle class nations save more than the very poor or the very rich. Harrod does not explain this kind of endogeneity of savings. In other words, this does not explain why growth rates systematically differ at different levels of incomes, and hence this is a model of neutral theory of economic growth. The macroeconomic balance S is equal to I can be attained only if financial systems are well established, and if all savings from the savers class are passed on to the investors class. Savers and investors are two distinct classes in an economy, which we must remember. Any amount of idle savings, unaccounted money, inadequate banking and financial services, etc. create lags in this macroeconomic balance. A third practical difficulty is that if there is immense increase in savings, then it is implied that incomes are also higher. This does not necessarily imply a very high growth rate, as new employment must be created to increase growth. Countries which have reached very high income levels have reached near full employment levels. Hence, further higher incomes cannot fuel very high growth rate. Here, students can view the growth rates of national income for the developed countries. The fourth difficulty is that if a country attains reasonable savings growth rate and also invests these savings in physical capital, but the productivity of labor is low owing to the poor state of health and education, then mere increase in physical capital will not push up the growth rate to desired level. Hence, remember we studied in earlier lectures that development of human capital is important to achieve economic growth. Fifth, in modern times, production is also a function of technology, research and creation of new ideas. Hence, along with investment in physical capital and investment in health and education, technological upgradation must take place and protection of intellectual property must be ensured. Sixth, several times developing countries borrow from abroad to bridge the gap between savings and investment. This creates a debt burden and a large proportion of increased incomes in the subsequent periods are spent in paying off the debt and thus growth suffers. If external debt is incurred for creation of infrastructure, etc., then it helps in increasing future incomes. But if debt is created owing to unproductive expenses, the future income generation will be lower and debt burdens will appear more difficult to manage. Seventh, for agrarian economies, public investment in agricultural sector helps in reduction of rural poverty as well as in increasing growth. Hence, it is important that these countries make the right kind of investment. This model assumes that fixed proportion of capital and labor are required to produce output Q in a growth process. If a producer is using quantities KO and LO of capital and labor respectively to produce an amount Q, then adding only capital or only labor will not increase output. Capital and labor must be added in the same proportion to increase output. If Z1 is labor and Z2 is capital, then the ratio K by L is fixed at B by A in the figure here, and it depicts a fixed proportion production function. Look at the figure. The model is not applicable if variable factor proportions are needed for the growth process. Let us summarize what we learnt in this lecture. We learnt that growth of national income can occur when savings and capital formation increase. We also learnt that population growth will reduce the growth of per capita incomes. We must remember here that the growth of income at a given capital output ratio in time period t plus 1 is equal to the capital formation from income in time t discounted at the rate of depreciation plus the savings generated from income in time period t. Students, I hope we enjoyed this lecture. After studying the growth process in this lecture, we shall see the solo model in the next session. Thank you.